All right, so let's continue our discussion on Spark. So what we're going to understand is a concept called RDD. Whenever you hear this term called Spark, you always hear this term called RDD, okay? And it stands for Resilient Distributed Data Set, right? And let's understand what exactly that means, okay? So RDD actually stands for what? Resilient Distributed Data Set. Okay, now what does it mean? Let's understand that in great detail. Okay, now today we are not going to create RDD. We will be doing that very soon, right? But then it's very important for us to understand what exactly this RDD means in terms of Spark. Okay, now let us assume that you have a data, and let's say the file name is data.txt. Suppose this is your data which you want to process, right? It contains some information, some employees data or some banking transaction or some sales data or whatever, right? So what you will do, you'll actually first create a RDD out of it, right? Now, how do you create the RDD out of it? We will see that in our practical. Don't worry about this, okay? For now, just understand what exactly I mean to say when I say RDD, okay? Creating an RDD means creating an object in Scala program. Okay, so when I say I want to create a RDD out of it, literally from a Java point of view, from a Scala point of view, it literally means an object. So you create an object and that object is called as RDD. Okay, but then what does it mean when you say resilient distributed data set? That's the important thing, right? So now let's assume that this data is of 200 MB. Okay, this data is of 200 MB. And we want to create this data, we want to create a RDD out of it, right? So when you want to create a RDD out of it, what will happen is internally this data would be loaded in memory. Okay, so let's do one thing. Let us try to visualize this from Hadoop point of view, SDFS point of view, as well as from Spark point of view, so that you are very clear. So see, you will have a Hadoop cluster like this. Let's assume this is your Hadoop cluster, a 5-node. When I say 5-node, I'm just talking about data nodes. I don't care about the master nodes. I'm just talking about data nodes. Okay. So let's say this is my Hadoop cluster wherein Hadoop is installed and we have created a SDFS out of it, right? And then we have also installed Spark here. Okay. So it's a Hadoop cluster. We have installed Hadoop. We have installed SDFS all together, and we also have installed our Spark in this whole cluster. And then the first thing what I would do is I would load this data into this SDFS, right? So you write a command called hadoop fs-put and all. So you write that command, and what happens is the data would be divided into blocks. We know it, right? So the data would be divided into blocks, and these blocks are basically stored in your machines altogether, right? So what the block size of Hadoop 3, guys? So Hadoop 3 default block size is 128 MB, right? So the default block size of Hadoop 3 is 128 MB. Okay, and if I say that it's 128 MB, then what would happen is this 200 MB of data would be broken down into blocks, multiple blocks. In our case, this would be divided into 2 blocks. Okay, so what will happen is data.txt would be broken down into 2 blocks. I'll say B0 and I'll say B1. This block would be of 128 MB. And this block would be of the leftover. How much is the leftover? 72, right? So one block would be of 128 MB. The other block would be of leftover size, that is 72 MB. Now these 2 blocks would now sit on your SDFS, right? So when you say hadoop fs-put, you write that command. What would happen is these blocks would be copied. B0, let us say B0 is here, and let us say B1 is here. And then, as you know, in Hadoop, we also have a concept of replication, right? So the replication can happen on these blocks so that if there are any failures, your data is not lost. So let's assume the replication factor is 3. So B0, okay, second copy, B0, third copy. Okay, so original copy, one more copy, one more copy. So the total copy of B0 is 3. Similarly, B1, let's say 1 copy here and another copy here. So that's how the data would be distributed eventually, right? Okay, now since you have this data B0 and B1, now what you would do, you will say I want to create a RDD out of it. Okay, and how do you do that? I'll show you the code, but then don't take it so seriously right now. sc.text file. You write something like this, SDFS location. Okay, we'll see that practically in our upcoming lesson. So you basically create a RDD like this. You'll say, well, data RDD is equal to. That's how you basically create a RDD. Okay. So code wise, that's what you write, but we will talk about this code later. Now, our objective is to just understand the concept of RDD. Okay. So what we did is we said, this is my SDFS location, and I know that my data is here and here, and I wanted to create a RDD out of it. Done. So when you say RDD is created, what would happen? Internally, this B0, see, this B0 is in your SDFS. So these are actually present in your disk, and this is a node, right? This is also another node. This is also another node, and so on. These are all nodes, and every node would have a CPU. Every node would have a memory, right? So let's assume the memory of this machine is, let's say, 64 gigs. Okay, the memory of this machine is 64 gigs, right? So all these machines has a memory, that is RAM of 64 GB. Now, can you tell me, can I hold this B0 completely here? Yes, why not? Because my B0 is hardly 128 MB, and it would take little space to hold this 128 MB, right? So this 128 MB of data is loaded in your RAM, right? Similarly, on this node, you have one more node here where you have B1, and this B1 is of just 72 MB, right? So this 72 MB would basically occupy little space, right? And that's how the data would be loaded in the memory whenever you are trying to execute your program, whenever you're trying to like create a RDD and then do some operations on that RDD. Okay, and that is how it actually works. Okay, so your Spark internally has a concept of partitions. We'll talk about that as we encounter them, right? But then right now, what you need to understand is the data is loaded in your memory RAM. Okay, done. After that, you will do some operations, like you'll say data RDD dot, maybe you'll say something like count. Okay, so see, what you're doing is you're just saying data RDD dot count, and what will happen is it will actually give you the total number of records that you have in this data.txt file. Okay, but how does it work? See, from a programmer point of view, what you're doing is you are just creating an object. From a programmer point of view, you have just created an object called data RDD. Okay, and you started now doing some operation on that data RDD. Internally, under the hood, what would happen? The same operations would be done here as well as here, right? So in count, what are you trying to do? You're actually trying to get the count out of it, right? So what will happen is you get the count of this, you get the count of this, and altogether both this count would be added, and how much you get? The total count, right? So from the programmer point of view, this is what you write your code in Eclipse or in IntelliJ, right? Or in let's say Jupyter Notebook, whatever, right? So this is what the code you will write on your editor, okay, on your editor. And when you run this program, internally all these operations would be executed in your cluster, right? Because Spark is also installed here, right? And that is what we call a RDD. Okay, so in a plain simple English, if somebody asks you what is an RDD, you should say RDD is a object, a distributed object. Okay, see here, RDD is an object. Okay, but then when I say it is a distributed object, what do I mean? I mean that when you do any operations on that RDD, you will feel like you're actually doing an operation just on that object, but internally under the hood, all those operations are actually done on the respective data set. Okay, and whatever you write your logic, all this business logic would be executed on all those machines wherever your RDD resides. Okay, so that is a simple definition of your RDD. So RDD, from a programmer point of view, it is just an object for me. I just create the RDD using this technique or many other techniques. We'll see that. And once you create the RDD, all that you do is you just write your business logic, what you want to do with this data, right? And then as you write all this code, internally all these instructions would be sent to all your machines wherever that data is residing, and they are loaded in the memory, and hence all your instructions would be executed in those nodes, and finally what you get the output out of it. Okay, so you can also say something like this. You can say data RDD dot collect. Okay, we'll talk about this, or what are the things, what exactly they are doing all together, right? So that's what you can do, and you can do a lot of operations one by one. I can say I have loaded the data. Okay, now I want to filter that data, and I want to remove all those records where the customer age is less than 18. So maybe you do something like this, rdd.filter, and let's say I got some data, and then I'll write some logic here. Age should be greater than 18. Only that, give me those records. Remaining records don't give me, right? So you get another RDD again. So that's how basically you write the logic of Spark. Okay, so that's how you implement your Spark. So now let's take one simple example. What I want to do is, maybe my requirement is like this. Let's load student data. Okay, get only students whose age is greater than 18. Get school name, phone number of such student. Okay, so let's say this is my requirement which I want to solve, a very simple requirement, and then you want to save this file into SDFS. You can also do that. Okay, we will say save the data in SDFS. So this is what you want to do, right? So now from a coding point of view, from a developer point of view, loading a student RDD, you'll do like this, right? So you'll say, well, student RDD is equal to sc.text file, and you give the path, whatever path you have for that student. Okay, now the next was get only student whose age is greater than 18, right? So now again I'll say, okay, I have to create another RDD. Well, student age greater than 18 is equal to, you will filter this RDD now, right? So you will say student RDD dot, okay, this student RDD dot filter, what is the condition? Age is greater than 18. We'll see how exactly you can get this out, all this information, right? So you are filtering the data based on age. So what you get another RDD done. Now you'll say, well, get me the school name and phone number only. Now say few details is equal to, now you will start working on this RDD. You'll say, I want to work on student age greater than 18 dot, probably you'll say map, and then you'll say give me only school name and phone. Okay, so you'll do something like this. Okay, so this is not this exact code. We'll look into the exact code as we start implementing it. Okay, I'm just trying to give you a high level understanding how exactly you are actually going to write your RDD. Okay, done. After that, you may say, I want to write this data into a SDFS. So you may say few details dot save as text file, something like this, and you give your SDFS path. Okay, when you do this and when you run your program, what would happen is your data was present in your SDFS, right? And those data would be loaded into your memory with the name student RDD. So let's try to understand how exactly this behaves in your cluster itself. So data.txt is here. So it is B0 and B1 and their copies are present. Let's assume we have chosen these two for processing. Done. Now the first thing is st.text file. The first line is st.text file. The file would be loaded in the RAM. Done. Okay. Now on that file we are doing some processing, right? So this processing would happen here itself, and this RDD, student age greater than 18, another RDD would be created here. See, this was the data loaded, and once in this RAM you have the data loaded, then you are creating an RDD. So this RDD would be created here itself. Okay, so on this data, that RDD would be created. Done. After that, you are saying student is greater than 18. Now on this data, we'll start doing some filter, and you get the result here in another RDD. Okay, again you have created another RDD again, dot map. Again it will give you another RDD. So you have another RDD here, which will have lesser data here. Now this is what you want to write to your SDFS. So when you write this to your SDFS, it would go and sit as another block, whatever, right? So if the file size is less than 128 MB, then mostly it would be a single block. Is not it? It should be a single block. And if the file size is more than 128 MB, then it would be a multiple blocks. So if this data was of 128 MB and you are filtering the data, that is, you're removing couple of records, you are getting few records out of the entire columns, you're just trying to read only few columns, then I personally believe that the size will never exceed 128 MB, because you're filtering as well as you're getting fewer details. So in that case, the data would be written down to your disk as another block, right? The path would be this. Okay, so I hope it makes some sense to you. We have not done it practically, but I just wanted to give you a high level understanding on what is an RDD, right? So any operations you do, it looks like you are literally writing a code, but under the hood, when those codes gets executed, then all these things happens in your memory. Okay, so we'll look into this examples with various use cases and scenarios as we move on with the program, because I would show you how the data would be loaded and how the RDDs are created, what kind of RDDs are created, will there be any shuffle and sorting, all these things we will try to figure out as we move on with our program. So I also want to add one thing here, like Spark has a lot of concepts, like the main thing that you should learn on a Spark is RDD, okay? But then having said that, there are sometimes possibilities that you may have a data in a columnar format, okay? And you might be able to represent them in form of tables, okay? In such cases, you can also use data frames, right? But then as I said, like most of the time your use case could be, okay, I have a customer data and I want you to find out maybe what was the highest transaction that this customer has done on any given date. So to solve such problem, you can definitely use data frames, but then you should also focus a lot on building your concept and foundation on RDD, because you cannot solve every problem using data frames. Okay, now I have worked with previously I've worked with a startup, I worked with Apple, wherein we were actually trying to solve a super complicated problem, and all those problems cannot be solved using data frame, and hence we had to use RDD. Okay, so the good thing is, when we do our project as part of our 40 hours of program, you will be doing the same thing that we have done in my startup. We will be trying to replicate the same use case, and then you will see the superpower of RDD. And then you ask this question to yourself, would you be able to solve this problem using data frame? And your answer would be no. Okay, so as a Spark developer, you should basically focus on RDD as well, because SQL query anybody can write. It's easy to work on data frames, but then like sometimes the use cases are so tough that you will say no, RDD cannot solve this problem. Okay, let's move on and we'll continue our discussion. So now let's try to go through our document so that we don't miss anything, right? Okay, so now the topic is reading the data from memory versus disk. As I said, reading the data from the disk is very slow as compared to reading the data from memory, and I want you to understand how much slow it could be. Okay, see here, at any point of time, it's a CPU that actually processes your data, right? So no matter what programming language you are using, the core, the CPU is something that actually processes your data no matter what. Okay, now a CPU can read the data from memory at this speed, 10 GB per second. If you are reading the data from a memory, that would be this much fast, right? At any given 1 second, it can process 10 GB of data. Now, similarly, the disk, it can read at the speed of 100 MB per second. Again, if you have SSD, solid state drive, these days everybody is using SSD, right? So, and we say that SSD are fast. And the reason is because it has the capability to be read at the speed of 600 MB per second. Okay. Now, if you're using some network, your data is not there with you. The data is present in some other network and you are reading the data through the network. The CPU can read the data either at 125 Mbps per second or at 1 GB per second, okay, depending on what kind of network you are using. Now, there is also concept of rack. So from rack, the speed could be at a rate of 0.1 GB per second when the data are loaded in two different racks as they have to jump between the switches. Let me show you one thing. See here, all these boxes, what you see, these boxes, these are called as rack, right? These are called as rack. And in all these racks, if you see, there are tiny devices. All these are your nodes. Okay, you don't get to see a laptop there, right? So with the motherboard, with the screen and all, so you will just see a node, and each node actually means it has its own processing unit, right? It has its own core, it has its own memory, and it has its own hard disk, right? So that's what you have. So these are all the nodes of your Yahoo cluster, okay? And if you see all these nodes, right, now this is rack 1, this is rack 2, this is rack 3, this is rack 4, and so on. Now suppose I have a machine here, a core here, a CPU here, which wants to read the data. Now you tell me which one would be much more faster, reading the data from same rack or reading the data from different rack? Of course, reading the data from same rack would be much more faster. Is not it? Because if your data is on second rack, then it would take little time. Is not it? If the data is here on the second rack, then it would take little time because of the network, because there is a switch involved. Every rack would have one switch which can help you to connect through different racks, right? So if one CPU from one of this rack is trying to read the data, and that data is residing on some other node, and that node itself is residing in some other rack, then the data movement would be really slow, is not it? And that is what we mean in this example. From rack, it will take 0.1 GB per second when the data are located in two different racks, right? So one data is here, one data is here, and then the CPU wants to read the data which is completely from the different rack, so it will take a little more time. Okay, now from rack at 125 Mbps or 1 Gbps, based on what kind of like networking you are using, if the data are located in two different node of the same rack. So which means if you are trying to read the data, and let's say the CPU and then the node is present on the same rack, then it would be faster, okay, than this, right? So that's what we wanted you to understand. Now I hope you understood why the processing in Spark is really fast. The reason is because it has the ability to read the data at 10 GB per second, and if you are doing it on a hard disk SDFS mode, then it will take it can read only 100 MB per second. Okay, now I have collected this information way back in 2016, okay, and it is possible that due to technology advancement, like the configurations might have improved a little bit, right? But more or less the equation would remain same, right? More or less the equation would remain same. The thing that I want you to understand here is, like if the data is in memory, it would be faster to read. Okay, nobody would be asking you this question in the interview, can you tell me at what speed the data is read if it is there in the memory? Nobody would be asking you. It's just for your knowledge that you should understand, if the data is in memory, then it would be faster. If the data is on disk, then it would be little slow. If the data is on SSD, then it would be faster than disk but slower than memory, and so on. Now let's move on. Need for the Spark. So need for powerful engine that processes the data in real-time streaming as well as batch mode. As I said, Spark can process the data in real time, as well as you can do a batch processing, and so on, right? And need for the powerful engine that can respond in sub-second and perform in-memory analytics. There are some scenarios where you want to say, I want my system to be so perfect that it should give me a response within sub-seconds, maybe 0.5 seconds, and so on, kind of stuff, right? So in that case also you can use a Spark, and we will talk about that as we move on. Okay, what is a Spark? We know it now, right? So just a recap. Apache Spark is a powerful open source processing engine which provides a real-time streaming as well as batch processing with speed, ease of use, and sophisticated analysis. And Hadoop is effective for storing huge amount of data cheaply. The computation it enables with MapReduce are highly limited and uses a high latency batch model, which means there would be a delay in the processing and getting the output. That is what we call a latency, right? So the moment I say I want to process this data, it takes a lot of time to process that data because your MapReduce reads the data from the disk, and that is what makes it all slower, right? And we have already discussed about this diagram earlier, that whenever you're trying to deal with a MapReduce job, it basically reads the data from disk, does some processing, and writes the data back to the disk. But if you look into this diagram, this is all about your Spark. You have the input data on disk on your SDFS, and you did some you wrote some code like sc.text file. The data got loaded in the memory, done, okay. And then what you did is you started writing some actions on it, map, filter, okay, and then a lot of such things, reduce and a lot of such things. We'll look into that slowly one by one. There are so many things that you can do, right? So you wrote all your instructions likewise, and what happened was everything was processed, and the output, the temporary output, right, so are all in the memory itself. See here, input data, I did some action on it, the output what I got is on memory, because I did not say I want to write it on the text on a file. Okay, I said okay, this on the memory, good enough. Now again I'll perform another action on it, again the data would be written on memory, again you perform some action, again the data would be written on memory, again you perform some action, again you have the data in the memory, and you have a final output this, and this final output you can then say I want to save it to a file, I want to save it to S3 bucket, I want to save it to Elasticsearch, I want to write it to Kafka, I want to write it to database. It's your choice. It's purely your choice. You can write the data to different sources altogether. Okay, as well as you can read the data from different sources. I can say I want to read the data from Elasticsearch, do some processing, write the data to database. Okay, so it's perfect, purely a business use case. So introduced by UC Berkeley in 2009, it is a general purpose distributed system that can run up to thousands times faster than MapReduce, and it provides API on Java, Scala, Python, and R, and hence the programmer can choose the language of his own choice to write the Spark job. It can be well integrated with Hadoop and can process existing data. So if you already have your data in SDFS, you can directly, like set up your Spark, start reading the data of that SDFS. You don't have to really worry about how do you convert the data, right? Because Spark supports a varieties of data set which you can read from. Okay, now we started with this, right? RDD, resilient distributed data set, and as I said, that is basically the very common term that you will ever hear whenever you are learning Spark, RDD. Okay, and RDD is basically what? A distributed object, we will say. From the programmer point of view, I create an object called RDD and it's a distributed. That means if I perform any operation, then that operations would be performed on all the machines that is actually holding that data, right? It looks like you are doing some operations on the object, but actually the operations are happening on the data, which is actually represented by that object. Okay, so let's look into this. So RDD is the basic abstraction in Spark. Done. It represents immutable partitioned collection of elements that can operate on in parallel. As I said, you have a file of 200 MB. You loaded that data in Spark. It was since the file was of the 200 MB, the data was broken down into two blocks, B1 and B2, because of SDFS property. And since you are now trying to load the data would be loaded in the memory wherever they are residing, right? And then all the operations, whatever you are doing, would basically be performed on that. And one more thing you will need to understand here is RDDs are always immutable. What do you mean by that? RDDs are immutable means, see here, we had written some steps, right? Like for example, create a RDD, done. After that, we said, okay, on this RDD, I want to apply filter. Again, I said, on this RDD, I want to get few, columns, right? So whenever you do any such, whenever you write any such logic, what will happen? Each operation would give you a new RDD. Okay, which means sc.text file. Let's say it gave you one RDD, RDD1. Okay. Now, when you said student RDD.filter, it will give you another RDD, completely a new RDD. Okay, and hence the first RDD and second RDD are completely two different, which means you cannot change the RDD once it is created. On that RDD, you should do transformations, right? You should run your actions and all. And every time when you try to do a transformations, it will basically give you a new RDD. The old RDD will not be modified at all. RDDs are immutable. That's what you need to understand. Okay. Now let's move on. So the type of operations on RDD, usually you can perform 3 operations. Okay. So we can perform 3 type of operations on any RDD. Number 1, that is a transformation. What is a transformation? Creating a new RDD out of old RDD. They are called as a transformation. For example, I have a RDD of employees and all the employees are getting some salary. I want to write a code that can help me to increment the salary of each employee by 20%. Okay, so I wrote some code like this. First I said, let me create an employee RDD. Done. Then I'll say employee RDD.map for each such employee, get the salary and increment the salary by 20%. And what it will give me? It will give me another RDD, right? So if you see, your transformation will always help you to create a new RDD. You get one RDD and you write your business case, what you want to do on this RDD, what do you want to modify, or what do you want to extract out of it, right? And these processes are basically called as transformations. Okay, so that is one thing. The next thing is they are lazy in nature and gets called only when some actions are executed, which means in our previous example we said, okay, I have created sc.text file and I said it will create an RDD. Done. Okay, and then I said student RDD.filter age greater than 18. I said it will also create another RDD. Done. Again, I said, okay, we'll now get some few details. Student age 18 dot map, get me the student and phone number. Again, it will give me a fewer details, another RDD. Okay, but that is partially correct and partially wrong. What do you mean by that? So see, all these RDDs would be created only when you do some action on it. For example, save as text file. Save as text file is an action, right? It's basically an action because you want to do something on those data. You want to process it. Because if you don't process, how do you save the data into a file? Okay, so whenever you are writing this kind of statement, RDDs are not created unless and until you are actually running some action on it. Unless and until you don't say, I need it now badly, these RDDs will not be evaluated. RDDs would not be created. Okay, when you just write these three lines, the first three lines, and you don't write save as text file, then your RDD would not be created. It will simply create a DAG in its memory. Okay, the DAG would be ready, the execution plan would be ready. But then when you say, I want to do something now with this instructions, then only your RDDs are created and they would be evaluated. Hence, we call the RDD as lazily evaluated. So, which means RDD would not be created upfront unless you don't need it. Okay, whenever you have a requirement, you perform some action on it. At that time, only the RDD gets created. Okay. Now, the second thing is actions. So, action means do something now because I need the output badly. So, returning some values back to the driver or writing the output to the destinations, they are basically called as your actions. For example, if I say count, RDD.count, it should give me some output because I want to know the count. Okay, if I say reduce means I want to do some aggregation on the data. We will see how actually you can use this. Collect means give me all the list of the data whatever you have collected in the RDD. Okay, take, give me something out of your RDD. So all these are basically called as your actions because all this actually helps you to execute your Spark job, right? So you have written a lot of Spark code, and unless and until you don't call action, nothing happens. Next, persistence. For caching data set in memory for further operation. So sometimes what happens, you may have a requirement saying that I have some RDDs, I want to persist it in memory so that I can use it again and again. Okay, that time you will basically use this technique called persistence. You want to save that RDD in the cache so that the RDD are not computed again and again. Okay, and if you want to do that, then you should basically persist your RDD. And in some cases, your Spark can automatically persist your RDD in the memory. We will talk about that as we encounter them. Okay, so persistence can be used for caching the data set in memory for further operations, and they are basically options to store the data in memory or in disk or disk. See, you may say, hey, I have a data of 1 terabyte and I have a machines whose altogether memory is not even 1 terabyte. Okay, let's say we have a cluster wherein the memory is only 200 GB and I have to process data of 1 TB. How do I do that? Do you mean that everything would be uploaded in the memory in form of RDD? And if yes, how it will basically be able to hold, right? Practically it is not that, it is not how it works, right? So what happens, few of the RDD would be loaded in memory, and when you need to load one more RDD, then some of the RDDs would be put back into your disk. So that's how basically the RDD works. Okay, so if required, the data would stay on your memory as much as possible. But sometimes what happens is you want to load another RDD, you want to create another RDD, and then there is no memory available, right? In that case, what should happen? Some of the older RDDs which were created very earlier should go back to the disk, so that I can get some space for the new RDD because I have to use it, right? So if you take this example, you created a student RDD, okay? You created a student age, okay? You created a few details, okay? And then you are saying save as text file. So when you say save in text file, what will happen is this will actually trigger your whole code, right? Is not it? And the RDD1 would be created, done. Then you filtered, RDD2 got created. It will also occupy some space. Again, you are doing some math. Again, it will create one RDD. Now at this moment, let's say this data, let's say we don't have enough space. So what will happen is probably this data, this RDD which was created earlier would be pushed back to the disk, and later it can be brought back or it can be recomputed again, whatever, right? So that's how basically the RDD would, would be shuffled around your memory. Whatever RDDs were created earlier, if they are not used recently, they can be flushed back to the disk for some time. They would be serialized to the disk, and later it would be again brought back. Okay, so we will also talk about that in our detailed lesson. I want you to understand how exactly it works. Now let's talk about the Spark modules, right? So when you are learning Spark, it's very important for you to understand what also you be learning as part of your big data course, right? So Spark module, you have a lot of modules on Spark. The first one is your Spark core. Okay, and this is very, very important. This is very, very important because unless your core is not clear, you will be struggling forever. Spark core, you should be very, very proficient. Sometimes in the interview, people would ask you to solve a problem, okay? And that problem is all about Spark core. You will not be able to solve the problem using Spark data frames. And the problem what you face is you will waste almost 15 to 20 minutes solving the data using a wrong approach. So understand that Spark core is super important here. Okay, next. Spark core, then you have Spark MLlib, okay, which is for machine learning. And if you guys are data engineers, then you don't even need this. You would not be using it. This would be used by the data scientist. This would be used by the data science team who actually works on machine learning, and they want to implement something and they want to run it on the scale. Okay, next, you have Spark SQL. Okay, and Spark SQL comes with a beautiful concept called data frame and data set. Right now, you should use this Spark SQL only when the requirement is such that you feel that I can represent this in form of table and I can run it as if I'm literally writing a SQL query. Okay, so if you have a requirement, if you're given a data set and then you are supposed to find out something out of it which can be represented in form of tables, then you should basically use Spark SQL. Okay, but as I said, depending on the use case, you have to first understand, can I solve this data using Spark SQL? Yes, go for it. Okay, if no, then come to a Spark core. Simple. The first priority, I would always say, you always give the first preference to data frame and data set if that can solve your problem. But keep in mind that they cannot solve all your problems. So if they cannot solve all your problems, then you should go to Spark core. Okay, next. Then you have Spark streaming, wherein what we do is we have the data, a real-time data, which is flowing into a queue, say Kafka, right? The data is continuously coming on the Kafka topics. And then what I would like to do is I would like to bring the data from the Kafka topics and start processing. So that time you can use Spark streaming, right? So if you are trying to do something on real-time streaming, then you should use Spark streaming. Okay. A real use case can also be something like this. See how, say you have a Twitter and a particular hashtag is trending. For example, Cricket World Cup. Okay, then what you can do, probably you can write some code that can start consuming this data, Twitter data, from the Twitter and push it to your Kafka. Okay, and it could reside on your Kafka topics. And then you may write some Spark streaming job to read the data from the Kafka topic. Okay, this is one use case. The other use case could be, there could be a lot of servers which is like sending some log, and all these logs are somehow coming to your Kafka. Now what I want to do is I want to write a Spark code which can continuously process that data. Okay, and if I get certain kind of errors, then I should do some action like sending an email to the folks, sending SMS to the concerned team, so that we can easily look into it, so that we do not have a problem of outage. Anything which is dangerous, anything which has to be fixed immediately, you can definitely use this Spark streaming to monitor it continuously, right? Okay, and then you have a beautiful concept called Spark graphics. Okay, and this graphics can be used when you want to create some relationship out of the data what you have, and these graphics can be used in fraud detection a lot. How? See, I took a loan of, let's say, 30,000 from the bank, and I defaulted that. Okay, I did not pay and I escaped something. The bank has all my details. Okay, now if, let's say, when I was taking a loan, right, the bank, I had the banking application, and this bank mobile banking application has read all my contacts, where few of my contacts read dad and mom, right, wife. Right now, if you default, don't you think the bank would try to reach to your family members to see where exactly you are? Definitely yes. Okay, that is something that can be done, and I'm sure you might not have even noticed that how it can actually be used, right? So this is one thing. The other thing is, tomorrow, see, I defaulted the loan, I did not pay the the loan amount whatever was given to me, and I just ran away from the city, right? Nobody knows how much like loan I have taken from Hyderabad, and I'm currently in Odisha probably. Okay, now suppose the bank has all my contacts. Now what happened was, my friend, he also went to the same bank to take a loan, but we are not talking to each other since almost 2 years probably. Okay, then if the bank reads my friend's data, contact data, okay, then the bank would come to know that, okay, in my friend's contact, my number is saved, my primary number is saved. Now the bank would be little suspicious, right? Should I give a loan to him or not? Okay, and maybe the bank would also try to check the call logs, not the recording, the call logs. This guy called whom at what time? Okay, and let's say my friend and me, we had spoken last time, maybe let's say 2 weeks ago, right? Now the bank would say, hey, this guy came for a loan, this guy knows a person who has already defaulted the loan, and this guy had a recent conversation with that guy, and he's coming to my same bank, right? So most likely I will not give him a loan. Possible. So that's how your Spark graphics can be used when you want to build a connections and you want to see the whole connections, right? So fortunately and luckily, we are going to cover Spark Core, we're going to cover Spark SQL, we're going to cover Spark Streaming, we're also going to cover Spark Graphics. We would not cover this Spark ML because this is a different zone altogether. Okay, and we need to have a machine learning expertise to understand this, and I really did not want it to waste a lot of time because our course is completely aligned to data engineering. Okay, so that's what we have, and we cover all these things in our 40 hours of complete program. Today it is 40 hours. Tomorrow, as we move on, the course size may increase and it may go to 50 hours, 60 hours, I don't know. Okay, so let's move on. So we have all these modules, we will be learning all these modules. Let's look into this highlights. Okay, so I'll again go back to my screen. Okay, so now we are talking about the modules in Spark, right? As you know, there are a couple of modules: Spark Core, Spark SQL, Spark Streaming, Machine Learning, and Graphics. And if you look into this diagram talks about the whole, like modules along with the programming language and all these things put together. Okay, so yeah, you have a Spark Core, a very core, right? Wherein you have the Spark code, that is basically the root, and Spark core can be programmed using Java, Scala, Python, and R. Okay, and then you also have a Spark data frame API, okay, which is actually built out of the core with additional functionalities. Okay, but then I would like to talk about that separately. We have a Spark SQL, wherein we would talk about Spark data frames and data set. And then you have Spark Streaming, you have Spark ML, you have Graphics, and there are a couple of two like components like BlinkDB and Tachyon, which is not a part of your Spark project, but it can be used, and hence it is considered as a Spark ecosystem. For example, if you talk about Hadoop ecosystem, we talk about Hive, we talk about MapReduce, we talk about Pig, we talk about HBase and all, right? But they are installed separately and used separately, is not it? So these BlinkDB and Tachyons are installed separately and used separately. Okay. Now, resource management, there are a couple of resource management, like you have standalone, you have Yarn, you have Mesos, you have Kubernetes and all. And this resource management can be helpful if you are running a cluster and you want everything to be negotiated by the resource manager, right? So I hope you know what is a yarn and what exactly a yarn can do for you. If you don't know, I would suggest you to look into my Hadoop lessons when I have talked about the Hadoop architecture, right? So let's move on. We'll talk about this as we move on, okay? Now, Spark contains the below modules: Spark Core. It is the execution engine for the Spark platform, and it provides in-memory computing capability to deliver speed, a generalized executions model to support a wide variety of applications. So remember one thing: whenever you are learning Spark, you should basically focus on learning Spark Core first. You are good at Spark Core, everybody would hire you, because writing data frames, writing data set code is hell easier than writing a Spark code. Okay. Now, Spark SQL, as I said, this component provides an execution engine where you can run your Hive queries as well. Okay. And the same Hive query that used to run on MapReduce now would run 100 times at least faster. Okay. Because of in-memory processing, is not it? What can your Spark SQL module allow you? It basically allows relational queries expressed in SQL or Hive queries to be executed using Spark. It allows user to mix SQL query and the functional programming, because when you are writing your Spark, most likely we would be using Spark with Scala. Okay. And in Scala, you write functional code, right? So there is a chance that you want to do something on Spark core, you want to do something on Spark SQL, and then mix them together, write some functional style of code. So you can mix them like they are a single unit altogether. Okay. Third, it provides a powerful integration with the rest of Spark ecosystem, that is integrating SQL query processing with the machine learning. You can also do some sort of machine learning job, write some machine learning job, execute them using the Spark SQL queries as well. Okay, so all these things can be done. We will definitely not be talking anything related to machine learning, as they are completely out of the scope of the course. The core of the Spark SQL is schema RDD. Okay, so and they are now called as data frame. So today we call it data frame, but earlier when it was introduced, we used to call it a schema RDD. Okay, and whenever you talk about Spark SQL, it's all about data frame and data set. Okay, what is the difference between them? Which one is better? We'll talk about that exclusively in that chapter. Okay, now, so you can say your data frame is just like a new kind of RDD with some super special feature. Okay, it has a schema associated, and then they do a lot, they have a lot of optimization which can help you to run the query much more faster than you would do it on RDD, right? Now the point here is, as I said, your Spark RDD and Spark data frame, if given a choice, I would always prefer Spark data frame if possible. Okay, but then as I said, sometimes there are use cases which cannot be solved using data frames. Okay, and that time you have no other choice than to get into your RDD level. And if you go into the RDD level, that's a programming level. You can customize your code like anything, literally like anything, right? In RDDs also, you can, in data frame also, you can create something like UDFs, which can help you to customize something up to certain extent. But as I said, there are certain requirements which your data frame can never ever be able to solve, right? And that is what you will see when we do our project, because the project is completely built on Spark core RDD. Now let's move on. So it can run the Hive query automatically without any modification, as Spark SQL still uses Hive frontend and Metastore in Hive. So you have a Hive up and running. You used to write a Hive query, and that Hive query was running on a MapReduce job. Okay, but now what you want to do is you want to run it on a Spark way, as well as you want to, like create some sort of RDDs and do some joinings all together, providing a solution. What you can do, write a code, and in that code itself, you write some sort of Spark data frames and read the data from Hive. We'll see that. And once you read the data from Hive, then you start integrating them together and then do whatever you want, and that can be done with ease. You don't have to really do a lot of things. It gives you the compatibility between your Hive data. You can write your queries, you can write your custom UDFs. If you're not happy with the functions given by Spark data frames, you can write your own UDFs, which can help you to get almost anything done. Okay, now it also provides the standard connectivity between JDBC ODBC driver through Samba connector with Spark SQL. A lot of applications like Tableau would use Samba driver to send SQL query down to Spark SQL and run them at scale. Now think about this. It is also possible that you integrate Tableau with Spark, right? Your Spark is running the query, it is processing a huge amount of data, done, and then those data will be visualized by your Tableau. It's practically possible. Okay, so all these things can be done. Spark, is quite popular, as I said, since last 5 years, and everybody is using Spark. And there are a lot of connectivity, like between various technologies and Spark. You will see Spark getting used almost with anything possible. You may see people are using Spark to process the data out of SAP or out of DB2, sorry, mainframe, and so on altogether. Okay, now let's talk about this Spark streaming. So Spark streaming, it basically enables a powerful interactive and application across both streaming data. It readily integrates with wide variety of popular data sources, including Flume, Kafka, Twitter. So whenever there is a requirement that you want to really read the data in a real time, you should basically use a Spark streaming, because that is very, very powerful. Okay, it processes the data in real time, which helps business to take decision in real time, right? Like fraud detection, should I approve him a loan or not, can be done in much easier way. So it integrates with the Spark batch and interactive processing. You can also do some sort of interactive processing in the Spark streaming. We'll see them as we move on. It processes the streams of data on hundreds of nodes. So the biggest advantage of Hadoop and Spark is they are all distributed processing, right? So they do not just run on a single machine. Whatever data you have, they would be streamed and they would be processed in parallel in 100 different nodes, so that it can give you the result much more quicker. Okay, and you can achieve second scale latency. That means you can have a latency of 1 second, 2 second kind of stuff, right? So the result would be as quick as possible based on your configurations altogether, of course. Okay, now it can receive the data from input source, process them in a cluster, pushes out to data store, dashboard, and so on. So it's all a business use case. Somebody may say I have a data in SDFS, somebody may say I have a data in S3, somebody may say I have already written the data in Kafka. So these are your sources, right? And then in the middle you will have your Spark streaming. You read the data, couple of data from SDFS, couple of data from S3, couple of data from Kafka, and mix them together in whatever way you want to, and then push the data into probably Tableau for the dashboarding, or push the data into Oracle and let somebody else do the dashboarding out of it. So it's purely a choice, right? So you can do a lot of stuff altogether. Okay, so it can receive the live data stream from Kafka, Flume, ZeroMQ, Twitter, etc., and can process and write the data to the database, SD databases, and dashboard, and so on, right? Again, Kafka can handle 2 lakh events per second for a single request, single broker, which means it's amazing, is not it? In 1 second, Kafka can handle 2 lakh requests, wherein your Spark can start consuming those data, process them, and then give the output back to Tableau or maybe to the database, whatever way. Okay, it's also it also has a way to analyze the real-time streaming of data coming in, like from Twitter, and do some NLP on it. Again, NLP is basically I would say a technology for the data science, and we would not talk about this. It's all about the natural language processing. Now, in 2012, Spark streaming was able to process about 16 million record per second on a 100 node cluster. This make it 2 to 4 times faster than other system like Storm and Yahoo S4. Netflix also uses Spark streaming. So think about this. In 2012, somebody was just doing a benchmarking. I believe probably the creator itself, Matai Jaharia, right? And what they were able to do was they were able to process 60 million records per second. It's not that huge, it's huge, right? And again, Flume and Kafka can be used as a buffer for Spark streaming. So you have a Spark streaming as a processing framework. All the buffer data can be either stored on Kafka for temporary basis or on Flume, and you read the data from this Flume or Kafka continuously. I would prefer Kafka because that is much more advanced and much more popular. So you keep your Kafka as a buffer, which will keep your data in the Kafka topics under the partitions, and from the other side you can still write your Spark streaming job and consume the data and process it all together. Okay, so this diagram says it all. You have a Spark streaming wherein it is reading the data from few sources, doing some processing, and writing the data to few of the sources. It's possible to write the data in one or all three, or you can have much more other output sources as well. Okay, now again you have a Spark ML which is basically used for machine learning. I would basically, like bypass this discussion because it does not make any difference to our course. I just written this point. I would suggest you to just go through these notes and see all these things together. You would get these notes in the in our LMS itself, and you can refer to it from there. Okay. Now graphics, we talked about this. As I said, it can help you to create a connection, like a Facebook friend, right? You are my friend and somebody else is your friend, and most likely then like the Facebook would say people you may know. Maybe you know this guy because he's a friend of yours, and like, so most likely you know him, and he's a friend of so many people, so most likely you also know him, right? So that kind of relation we can create, right? And this can be super useful whenever you want to create a connection and get some meaning out of it. As we discussed, it can be used when you want to detect something suspicious. You can use them to understand the whole topology of the network, and they are used in various different like use cases altogether. Spark R is basically a way of writing your Spark job using R, and data science team basically uses it. We will not be using it. We will be just sticking to Scala, and we will be just doing data frames and all, right? But then if there are people who are very good expert in R, then Spark says, hey, I can help you to that. To do that, you use the Spark R, and then you write all your queries on R, and we will get it processed in our Spark framework altogether. Okay. Now let us talk about this BlinkDB. Okay, this is something which is out of your Spark. You have to install this separately, work on it separately. Again, we will not be doing it in our course because they are hardly used. But then I just wanted to mention it so that you have something in mind that okay, there is some concept called BlinkDB. Let's understand what exactly it does. So it is basically an approximation query engine for running interactive SQL queries, which means you have a data and you want to write a SQL query, and it is an approximation query engine. What does it mean? Let's see. Okay, it will allow you to run the SQL query, and you can also specify when exactly do you want to get the result, say 5 seconds. For example, see, let's say you have written a big query, you have a huge volume of data, and you want to run some query on it, right? And you would like to say, I don't want you to wait till the query is completed. I'll give you 5 seconds. Tell me the result. Okay. And in the 5 second, what it would do, it will give you all the result with some sort of accuracy. For example, let's say I may say, I have 1 lakh employees altogether, and I'm running some query, and I said, I want you to give me the result in 5 seconds. Okay. And my query was like this: give me the list of all the people, or give me the count of all the people whose age is more than 35 and whose salary is more than 40 lakhs per annum, right? So I should get a count. I should get a count, and I should actually get a proper count. I should get 40. If there are only 40 people who are more than 35 years and getting more than 40 lakhs per annum, I should get that 40, right? But this approximation engine would say, okay, you gave me 5 seconds and my answer is 38, not 40 really. Okay, so that can be done, and it can be used when you want to get some approximate count, and you are really not worried about the accuracy. Okay, that can be done. The query may be running against terabytes of data, but at the end of 5 seconds, it will come to you with an answer along with an error bar saying that the result is 95% accurate, and so on, right? So sometimes you may want some sort of approximate output. You don't care about the actual output. For example, based on the data, I may say what the percentage that it would rain tomorrow, right? Now, does it really matter if it says 100% or 90%? Does not matter, right? Because even if it says it is going to rain 100%, or even if it says it is going to rain 97%, most likely it will rain, right? So in solving such problem, you will basically be using this tool. Okay, BlinkDB. BlinkDB, like blindly, it will give you some output. Okay, now again, you can again rerun the query and say, run as long as you want, give me the answer as soon as you have around 98% of accuracy. That can also be done. Okay, so it basically uses sampling, and it does not have to do a full table scan to give you the aggregated result. And let me give you a little information about this BlinkDB, which I've captured from their website altogether. Just Google it out, BlinkDB, and you should be able to get the same screenshot, whatever I'm showing you here. BlinkDB has been demonstrated live at VLDP 2012 on a 100 node Amazon EC2 cluster. answering a range of queries on 17 terabytes of data in less than 2 seconds, right? Over 200x faster than Hive with an error of 2 to 10%. So see, this is how basically you write a query on your BlinkDB. Looks very similar. It says, give me the average session time from some table where city equal to San Francisco. Let's say I want to find out what is the average time an Indian guy is spending on TikTok, which is banned, okay? And it does not matter if I get the report that they are spending 1 hour or they are spending 55 minutes. It's same thing for me, right? 55 and 1 hour does not make any difference. So if you have such kind of requirement where you are not really looking for real quick data right now, you're not really looking for accuracy, right? You can use this BlinkDB. So see here, you can write something like this: give me the result within 2 seconds. I don't care about the accuracy, but also tell me what is the percentage of accuracy, right? I don't really care about 100%, but give me the accuracy. That's what it is. Okay. Now similarly, select average session time from table where city equal to San Francisco, error 0.1, confidence 95.0. You can also do something like this, wherein you can say, I want you to give me the result whenever you are 95% confident, and I'm okay if there are errors for some reason, but then confidence should be 95% at least, right? Your answer should be 95% sure. That also can be done. Okay. Now again, this example is copied from the official homepage of BlinkDB, whatever. Similarly, you have a concept called Tachyon. Now let's talk about this Tachyon. Okay, what exactly this Tachyon is? Again, this is a third party. It does not come with the installation of your Spark, but it is worth understanding what exactly it does. Okay. Now see this. SDFS stores the data, but are relatively slow. You know it, right? That SDFS basically stores the data on disk. And Spark is an in-memory computing system which loads the data as the process starts, and the data is removed from in-memory as the process is over, which means you have written a Spark code, right? And what you did is you started running a query, some steps, you wrote some transformations, wrote some business logic, and at the end of the day, you said, rdd.save as text file, the data would be written on the text file. Okay. And let's say your Spark job is closed. And if your Spark job is completed, what would happen to all these RDDs which were loaded in memory? Definitely it would be destroyed. That's not it. Because that's what it should be doing. Okay. All right. Now, what if there are some requirement changes and you have to do some code changes and start your job again? In that case, the data has to be loaded again. So what I'm trying to tell you is, you have a data, you want to perform some operations on the data. The first thing that you did is you created RDD, done. Then you started executing a lot of steps, done. Finally, you wrote that data into a database or on SDFS, done. And once all these things were done, your job is completed, right? And all this data which you have loaded in RDDs are gone. Okay. Now, if I run this program again, then everything would again happens again, right? Which means again, the data has to be loaded in the memory, RDD would be created, and then the transformations, everything would be executed. It would happen again and again. If there is little code change, then most likely all the steps would be done, would be executed again, which you don't want to do. So what you want to do is, I want to create a memory wherein I would say, I want to keep some of the intermediate output into that Tachyon, so that if I start my Spark job again, I should be able to make use of the data which I have already saved it in Tachyon. What is the advantage? The advantage would be, even if you are restarting your services, the data which you have already pushed in your Tachyon would be available till you don't say, I don't want this data anymore, right? And this is super powerful tool. When should you be doing this? Probably, let's say you have some sort of data and you have already done a lot of customization on that data. You have improved your data, and now you would be using that data again and again, and you don't want them to be loaded on disk. You want them to be available forever, so that every other team can use it, right? So you can push it to Tachyon and let the Tachyon data be utilized by every other person, right? So that's what it can do. So see here, Tachyon is basically an in-memory based distributed storage that allows you to store data in memory, and that data can be accessed by many applications altogether. We can set up Tachyon in our Spark cluster and can load the data from SDFS, S3, GCP, and other file system and keep them in memory. You can store the data in any format like Parquet, Ebro, and can maintain compression like Snappy LZO. Stackion comes up with a file system API that can be used to load the data into memory and process the data using Spark. Tachyon further helps us to improve the performance of the program for hours to minutes. So think about this. You have some data. That data would be used by different data engineering team, right? I would also be needing the data. Other guys are also needing this data. And what would happen is basically when I write a program, when that guy writes the program, we all will end up with creating some other RDDs altogether, right? And because of this, what will happen is the data would be duplicated in your memory, of course, and that would lead to a lot of duplicates data which you are actually working on. So if you have a master data, why not push it on your Tachyon and let everybody use it? And whenever there is a new update on that master data, remove those data from the Tachyon and re-upload the master data, so that we don't load the data again and again from our Spark, and we'll just use the data from the Tachyon. What is the biggest advantage? The biggest advantage would be everybody would be using the same copy. And it does not matter even if your Spark job is running or it is killed, the data would reside in Tachyon forever. Okay, so hope that makes sense. Now let's talk about this resource manager. Okay, so see, whenever you are writing any Spark job, right, you basically need a resource manager, because at the end of the day, you are actually going to run your job across many nodes, right? And somebody has to decide which nodes will process your data altogether, right? So all these things would be done by your resource manager, and there are a lot of resource managers available in the market. Yarn comes with Hadoop, okay? Mesos, which was basically written as an original resource manager for Spark. You also have a standalone mode, like if you're just doing some sort of development, then you can use a standalone mode. You can also use a local mode. We'll also look into that. And you also have a Kubernetes, which was experimental, but I don't know if they are fully functional now. I have no clue. I have never used Kubernetes in my career. Okay, so most likely I've used Yarn, and it's a choice. And from a programmer point of view, there would be no code changes if you are using Yarn, or if you're using Kubernetes, or if you're using Mesos. Your Spark code would remain as it is. Okay, so now it's very interesting for us to understand that when Mattia Jaharia was developing the Mesos as a resource manager to Hadoop system, okay, he was asked to demonstrate the power of Mesos. So what he did, he wrote a small code just to justify that Mesos is a good project. So he develops an application to demonstrate the Mesos, and that little applications was called as Spark, because it sparks the Hadoop ecosystem component performing better. And later Spark became more popular than Mesos. Many people do not know about Mesos if they have not learned Spark, but Spark has gained a lot of popularity. Everybody knows what exactly a Spark is. A Spark is a big data processing framework, is not it? So all the above resource manager except local mode can be made highly available using a Zookeeper. Zookeeper is a great guy who actually helps us to register our multiple like resource managers and all, so that in case one resource manager crashes, the other resource manager can still help us to get the like a service served, right? So resource managers are made highly available just because of Zookeeper. So Zookeepers are also used in the real time, but it's all about installation and configurations. As a developer, you would not be doing anything on it. Now, file system then that can be consumed by Spark. So Spark can actually consume a lot of file systems, but out of the box, you can consume the Linux file systems, you can consume SDFS, you can consume Amazon S3, you can consume GCP file system, data from GCP. You can also consume the data from Windows, and there are a lot of other, I would say, plugins which can help you to read the data from various different sources. You can read the data from Kafka, you can read the data from like multiple other databases and so on, right? So we will be looking into this practically as we move on with the program. Okay, now it can almost read any file system and a NoSQL database now, like RDBMS, HBase, Cassandra, Neo4j, Mongo, Hadoop input format, Elasticsearch, and so on. Okay, now let's talk about the distributions. So see, when Apache Hadoop started, right, there were few companies who said Apache software is an open source, and the problem with the open source is they don't provide you a support. Okay, so many companies, they are afraid to use the open source because what will happen if something goes down in the production? Who is going to solve it if it is a real bug, right? And if you write an email to Apache Software Foundation, they will say, hey, you're not paying me anything and I'm not going to help you out, right? Everything comes with a cost, right? So few companies, what they did, they started creating their own version of Hadoop. So what they did, they took the raw Hadoop, they took the raw Apache Spark, they took the raw Hive and so on, and they started grooming it, right? They started modifying it, making a better framework, creating some UI which they felt is really important. And these companies are basically called as distributions. Why? Because they don't sell the raw Hadoop, they sell the fine-tuned Hadoop. Okay. Now there were CDS Cloudera, there are Mapr, Hortonworks, Databricks. So these are the four popular players which are actually distributing Hadoop and as well as the Spark to all the customers. Now, interestingly, what happened was recently Hortonworks was acquired by Cloudera. Okay, so Hortonworks company was there, Cloudera was also there. They were a competitor to each other. Cloudera, what they did, they bought this Hortonworks, right? Now Hortonworks is no more. It all is a property of Cloudera. Recently, the Cloudera then became a private company again. What do you mean by that? See, whenever somebody starts a company, for example, my company, Online Learning Center, it's a private limited company. Online Learning Center Private Limited. Okay, who owns this company? Me. Who runs this company? Me. Who funds this company? Me. Right? But later point of time, when the company is growing and let's say the company is making a good money, then the company can say, okay, I'm making a lot of revenue, like Udemy, right? They made a lot of revenue, and then they said, we want to go public, and they are listed on your stock exchange, and then it becomes a public company. So what happened? Hortonworks started as a private company, did something, got a lot of funding and so on, and then they became a public company. It had its name on the stock market. People were buying the stock of it. Okay, and then after some time, what happened? Recently, the Cloudera company, which was public company, was acquired by Clayton, Dubilier and Rice. We call it CD&R, and that's the company name, and KKR, that's the company name. They acquired that company and they said, now we will acquire you and you will not be anymore a public company. You would be basically under us. So what happened? That public company again became a private limited. Okay. So now the Cloudera, whatever they had, the stock and all, they are all no more, they do not exist anymore. So the people who have actually bought the stock of Cloudera, they would be given some money per stock, whatever it is. And I don't know whether it is a profit or loss, but then at the end of the day, the Cloudera made a lot of money because they were acquired by these companies, and these companies have paid almost $5 billion, if I'm not wrong, almost $5 billion. Just Google it out and you'll get a lot of information around it. Now, feature of Spark, I'm just trying to recap it. In-memory computation, faster speed, real-time computation, and low latency. Low latency, why? Because you can process the data as it arrives because of Spark streaming. And the other thing is the data are loaded in memory, and reading the data from the memory is very, very faster than the reading the data from the disk. Next, polyglot. That means Spark programming can be written using Java, Scala, Python, R. You have a choice of whatever programming language you want to use. You have 4 choice, and that's what we call a polyglot, which means multiple programming language can be used to write a Spark program. Next, Hadoop integration. It can be used to integrate with Hadoop so that you can start reading the data from existing SDFS, you can start reading the data from Hive, and so on. Machine learning models. Spark has a machine learning modules which can help you to write the regressions, classifications, logics, and all. And because of this, even the data scientist wants to learn Spark. Lazy evaluation. It computes only when it is required, which means whenever you create a RDD, the RDDs are not created really. It just creates a it just creates a logical plan. We call it DAG. And when we start running the job, when we start executing a particular action on it, then only that RDD gets created and evaluated. And hence your Spark is called as a lazy evaluation, and it computes only when it is required.